So we've talked about now a bunch of our like main or basic rules now. So we've talked about our power rule, which helps us with things with exponents. We've talked about our different trig rules. We've talked about our E and natural log rules. Yes. And then we've also talked about now our product and quotient rule. Yes. So your chain rule is basically the last of our big rules with our derivatives. However, it is one that comes up a lot on the AP test. So not that I would like, I don't know, that the chain rule and the power rule, probably like your two almost like most important rules that we have to know. Okay? Because they just come up so often. Alright, so the chain rule allows us to take the derivative of something that has stuff on the inside. What is another way of saying that? What type of function is that?
Composite.
Huh?
Function, like composite function.
Composite function. So we're going to be taking the derivative of something that has been composited. Yes? And we're going to do that through learning about some M&Ms. All right.
Yeah.
All right, everyone take an M&M. And you're going to put the M&M in your mouth, but you are not going to chew it.
Okay.
All right. So, our M&M, I'm going to pick blue because I like blue. Has a outer shell and an inside chocolate. And like I said, it is going to help us take the derivative of something that has stuff on the inside of it. So as you're sitting here not chewing our M&M, what is happening to the outside shell? You may now chew your M&M. What happens to just the shell?
It dissolves. Just a whole.
It dissolves, okay? So if my outside shell is dissolving, okay, does that affect the inside chocolate? No, right? So the same thing is going to be true here. When I'm taking the derivative, okay, our f, or our outer function, is acting as our outer shell. And our g is acting as our inner chocolate. And when we want to take the derivative, we are first going to take the derivative of just the outside. But just like our shell, as it melts, okay, our inside does not get changed. So the stuff on the inside doesn't change at first. However, then when we take a bite, okay, does our inside get affected?
Yes.
Yes. So we then have to multiply by the derivative of the inside stuff. We all need it. Now on your handout, and then sometimes like in textbooks and things, instead of a G, you will see it written as a U. Okay, it means the same thing. It just means that there is stuff on the inside, okay, that is not just an X. Okay, this is also on your foldable. If you want to put it on your foldable, so that you can refer back to it later. And then we're going to work out one of the examples to relate. Question? Oh. Alright, you may eat more of M&Ms now as we are walking through some of these problems. Now, notice we've had square roots in the past, yes? What's different about this square root versus the square roots that we've seen?
There's more in
There's more, right? We've just looked at square root of x, yes? This now has stuff on the inside, yes? We have an M&M, we have chocolate, yes? We all okay with that? Alright. Now, just like with our other square roots though, what is helpful to do first with this?
Change it into an exponent.
Yes. So, those types of steps still apply. I still want to write this as a 1/2. Are we all with me there? And then if we remember back to pre-calc, I know some of us have slept since then, okay? The hardest part of using your chain rule is not necessarily the chain rule itself, right? Most of us are okay at memorizing stuff. Once we have it memorized, we're pretty good to go. The harder part of these problems is deciphering which of my things, right, operations, is the outside stuff versus the inside stuff. So if we remember back to pre-calc when we did composition functions, we did some problems where you had to go backwards. Okay, I gave you a composition function, and I would say, what were the two functions that we had to composite to get there? Yes, no, maybe? You vaguely remember doing that? Which is basically what we're doing here, right? We're saying that this is my answer, okay? This is f of g of x. So now I need to try and break it apart into what was f, the outside function, and what was g, the inside function. So, what does it look like our outside function is? Okay, well, yes, but like the 1/2 is in the what? In the exponent, okay. So this is our shell. Now because it has stuff that's not just x on the inside, we're going to label it as just like u to the 1/2, or stuff to the 1/2. Which means, what is our inner function, or our chocolate?
U.
Yes, but for this specific.
X cubed minus
Yep. Are we all okay with that? And then if we were to take the derivative, okay, what is the derivative of something to the 1/2 power?
1/2 something.
1/2 something to the -1/2. It's just our normal power rule. All of our other rules still apply, right? So we're going to be combining our power rules, our E rules, our natural law rules, all of the other rules that we've learned are still there. We're just going to use those now in combination with composite rules. Alright, now what's our derivative of x cubed minus 9? 3x squared. Okay. So then, remember, so I have d dx of x cubed minus 9. I take the derivative of my outside stuff, which we just said is a 1/2, okay? And it's stuff, or u, right? So what's the stuff on the inside of my function this time? Minus 9. And when I take the derivative of my outside layer, does our inside layer get affected? Does our chocolate go away as our shell dissolves? No. So I didn't change anything about the inside, even though I was taking the derivative of the outside. However, eventually we do need to eat through our inside layer. So eventually we do have to multiply by our inside layer. And if we wanted to clean this up, we could. So we have a 3x squared divided by 2 square roots of x cubed minus 9. Now, for your response question, you're fine to leave it here on this second step. Multiple choice question, they are going to clean it up, and so you would see something like that at the end. What questions do we have there? So that's the one that's worked out for you, kind of on that second row. So now in your groups, you are going to work out the other 3 examples on that first table. Alright, so I think most of us have a good handle on our regular M&Ms, okay? Next up, we have what we're going to call our peanut or fun-filled M&M. Okay. It used to just be peanut M&Ms, but then over the years I've had people that are allergic to peanuts, and so now we have fun-filled, and there are lots of different flavors of M&Ms if you want to know. So basically, what we're looking at here, and I'm not going to make you put it in your mouth again, but we can hopefully think through the idea together, is we now still have an f and a G. But we also have our fun-filled center, which we're going to label as H. So I have my shell of my M&M still. We have our chocolate still. But now we also have a fun-filled center, so like peanut butter. Okay? So, thinking through, if we went through the same process as we did before, okay? If we were to just put the M&M in our mouth, as the shell melts, is it going to affect the chocolate or our fun-filled center? No. So I still take my derivative of the outside and leave everything else the same. Are we all okay with that? Yes, no, maybe.
Yes.
However, then we're going to pretend that we were taking a bite. Yes? And if you could like pause mid-bite, okay? As you have bitten through the chocolate, if I've just bitten through the chocolate layer, okay, has that affected my fun-filled center?
No.
No. So then we also have to multiply by the derivative of our g of x, not changing our innermost layer. But then finally we get to the fun-filled surprise inside. Yes? And we would bite through that. So then we do have to multiply by our h prime of x. Yes, no, maybe. Are y'all okay with that? Now, technically, right, could I continue to do this over and over again with as many layers as I wanted or needed?
Yeah.
Yeah. We stop here because this is the scope of this class, okay, of the AP test and what you would see in my class. You will see 3 layers. However, just realize that that same kind of pattern or idea could work with as many layers as you needed it to work with. Okay. Now we're gonna work these next couple out all together, just because these types are a little bit harder. Like you have more layers, which makes it a little bit more complicated. Okay. So I'm also gonna substitute, and I don't know why the worksheet. I don't know. I didn't make the worksheet, but like the 3 that are on there besides cosine squared are not fun-filled. They're just normal. And so that's what we're going to do a couple different ones. So on the first one, you can erase the 1 divided by x squared part. We're going to do this one instead. So sine of the natural log of the square root of 2x. So that's going to be your first row. Now, our next column is to rewrite if necessary. And this time it is necessary. Our sine and our natural log are okay. Yes, but what are we going to need to do with that square root?
It just into power of 1/2.
It needs to be a power of 1/2, but be careful. You can do this one of 2 ways. If you want this to be a 4-layer derivative, you can put 2x to the 1/2 altogether. Yes? However, do we also agree that the square root of 2x is also equal to the square root of 2 times the square root of x?
Yeah.
Yes? So we can treat the square root of 2 just as a constant. Yes or maybe?
Sure.
Which we prefer to do that because now it's only 3 layers instead of 4. So that's why we're going to rewrite it that way. So I'm going to rewrite this as the square root of x times x to the 1/2. Yes, no, maybe. Do we all see how I rewrote that? Alright, so what is our shell or our outermost layer?
Sine.
Sine. Okay, so my derivative of all of this stuff. Okay, so I'm going to take the derivative of my outermost layer first. So I have sine of u. So that's your outermost layer. you have another column on yours where it says candy shell. So that would be sine of u. What is our derivative of sine of stuff? Cosine of stuff, yes? So again, remember that as I take the derivative of that outside layer, so I'm just going to combine these now because I don't need it as a 1/2 for my cosine layer. Yes, don't maybe. So then what would be our chocolate layer? Or our next layer?
Natural log.
The natural log, yes? So that would be, so natural log of u would be your chocolate layer. And what is the derivative of the natural log of u, or of anything? 1 over whatever that stuff is. Yes, no, maybe. And then what is our peanut or fun-filled surprise inside? Yeah, my square root of 2 times x to the 1/2. Yes? No, the square root of 2 is just a constant. Yes? So it's not really going to do anything. The only part that I care about is my x to the 1/2. So what is the derivative of something to the 1/2 power?
1/2. That's something. That's the negative.
Are we all okay with that? Right? I bring down my 1/2 and then I subtract 1 from my exponent. So I get a negative 1/2. Now, right now, that answer does not look very nice. So we're going to clean it up a little bit. So notice that my square root of 2 is going to be on top. And my cosine of the natural log of square root of 2x is going to be on top. Then I have a 2 square root of 2x. And then my x is to a negative 1/2. So that would make it what? Square root in the bottom, right? Or I'll give it that. So I have another square root of x. What is square root of x times square root of x? Just an x, right? Yes, no, maybe.
Mm-hmm.
And then lastly, if we really want to simplify it, then what can we do with our square roots of 2 at that point? We could reduce them, right? Because this is all multiplication. So you just end up with cosine of natural log of the square root of 2x divided by 2x. And that would be our simplified answer. Again, this would be like, if I'm free response question, I'm leaving it in unsimplified form. If it's a multiple choice question, they are going to simplify it. Yes, no, maybe. What questions do you have on that? Yeah.
The peanut in this case is x to the 1/2.
It's technically everything inside your natural log. So square root of 2x to the 1/2. I mean, technically, I don't have it right here, but technically, we have a set of parentheses around that because it's being multiplied. Good question. Other questions? Alright, let's look at another one. This is going to be, instead of that square root that you have there, we're going to look at this 4th root. So how might it be helpful to rewrite this one? Yeah, my stuff, right? Whatever's on the inside to the 1/4 power this time. So what is then my shell or my outer function? Hmm? 1/4 power. Are we all okay with that? Yes, no, maybe. So stuff or u to the 1/4. would be your outer shell. What is the derivative of something to the 1/4 power? 1/4 u, or whatever's there, to the, not quite,
-1 and 1/4. -5/4.
not quite,
-3/4.
-3/4. Right, 1/4 minus 4/4 would be -3/4. Are we all with me there? We're still just subtracting 1 from our exponent. Alright, what is our chocolate layer? Tangent. So tangent of u would be your chocolate layer. What is the derivative of tangent of u? Secant squared of u. That one is. So I know y'all don't like your trig function, but your trig rules are way faster than all of your other rules. Alright, and then what is our innermost layer, or our peanut? X over 2. Now be careful. Dividing by 2 is technically multiplying by 1/2, right? It's just a constant. Yes? So this is technically just 1/2 x. So what is the derivative of 1/2 x? 1/2. Just be careful, because a lot of people start wanting to do like quotient rules or weird things when they start seeing that division sign there. But remember that it is just a constant. Yes, no, maybe so. Yeah. Yes. I mean, technically you could write that as a 1/8, and you can move your tangent to the bottom, but you're not going to have a bunch that simplifies that time. Now, on this next line, this is the most common one that you can see, so I do want to go over this one together. So we have cosine squared of 4x. And I know it's written in there so you can see it, okay? However, I do want to go over because like this is the type that you actually see the most often with your peanut or fun-filled, right? It's when I have a trig function just raised to a power. So just like I did with my tangent, right? We had to rewrite that tangent to the 1/4 power. It was all of tangent being raised to the 1/4 power. Yes? Which, what can be tricky about it when I have a whole number is we use this notation where the squared is next to my cosine. But remember that what that technically means is that I have a cosine of 4x all being raised to the second power. We just don't like to have the second set of brackets or parentheses, and so we use the shorthand notation of the squared being in between. Yes? And why that can be confusing is because just like with our 1/4, here my squared is acting as my outermost layer. But it can be kind of hard to see it when it's written like this first way. Are y'all with me there? So if I was taking the derivative of this, if my outermost layer is a squared, okay, what is the derivative of something squared?
2 something.
Yeah, 2 times that something. And most people will get that okay, but if they forget to rewrite it, what they'll skip is then what is the derivative of my chocolate or my cosine? Negative sign. So that's the part that most people forget if they don't rewrite it. Because then what's the derivative of our innermost layer? 4x. Just 4. Does that make sense? And again, if we wanted to clean this up a little bit, it becomes -8 cosine of 4x. Sine of 4x. Which I believe, yeah, if you look at the one that they have, they actually use the double angle property. If you remember that from our trig days back in breakout.
Yes.
Sine of 2u is equal to 2 sine of u cosine of u. So, but we would just leave it like that. Alright. What questions do we have on that? Yes, maybe so. Alright. So by now we should be able to fill in this. What is the derivative of f of g of x?
F prime.
F prime of
G of X.
g of x times
G prime.
g prime of x. Are we all okay with that?
Yeah.
Alright. Now I'm going to post these completed slides on Google Classroom. It's just really similar ones to the ones that are on your tables. I don't want to go over all of those, but I do want to go over this last one together. So if you need some extra examples, then you can look over the slides. However, I do want us to go over this. So you can put this one on the back of your handout if you want, or in your notes, whatever works for you. So I have y equals x squared times the square root of 1 minus x squared. What operation do I have in between there? X squared times the square root of 1 minus x squared. Multiplication. And what rule do we use when we have multiplication of two functions? The product rule. So like I said, remember all of our other rules still apply. Which means that if I have a product rule, I still have to do a product rule. But remember, notice I have a square root of stuff here. So what am I also going to have to use within my product rule? The chain rule. So now that we've learned all of our rules, right, we're going to have to use all of those things in combination with each other. Okay? So I'm looking at dy dx. What's the derivative of the first, or x squared? 2x. Do I change my second one for my product rule? Nope. And then what's my operation?
Addition.
Addition. And then I leave my first one the same, and I take the derivative of my second. And when I take the derivative of this now, what are we going to have to use? The chain rule, what we've been practicing. Our M&M rule, yeah? Okay. So, how might we rewrite this in order to help ourselves? To the 1/2, okay? So, what's our outer layer, or our shell? The square root, or our 1/2, okay? So, we bring down our 1/2. I leave all of my inside stuff the same. And then I have a negative 1/2. 1/2 minus 1 gives us negative 1/2. And then we still have to take care of our inner layer. What is the derivative of 1 minus x squared? Negative 2x. Okay, if we're going to clean that up a bit, notice I'm going to have an x cubed. Yes? Now I'm going to be negative. Notice 1/2 times 2 gives us what?
1.
Just 1. So those go away. And then I move my square root to the bottom. I got something that looks like that. Which means that, right, a chain rule within a quotient rule is fair game, right? Something with a natural log or any of my trig functions using a trig rule is fair game, okay? We've learned all of our rules now. Now we're just going to have to use those in different combinations with each other. Questions, concerns, comments on any of that?